Okay, let's take a look at the graph of y equals 1 over x squared minus 1. So let's start by drawing that graph. So if we remember, we find a vertical asymptote by setting the denominator equal to 0. So this one I'm just going to factor by adding 1 to both sides, and then I'm going to square root both sides, and x equals, if we remember from last year, plus and minus 1. So notice we have a vertical asymptote at both x equals negative 1 and x equals positive 1. So our horizontal asymptote, we're going to look at the function. We have 1 over x squared. And we learned from horizontal asymptotes that 1 is really 1x to the 0, and 2 is greater than 0, meaning that our degree is greater on the bottom, and if the degree is greater on the bottom, then we know that the horizontal asymptote is y equals 0. So we can put that horizontal dotted line in there. And then we're probably wondering, what does the rest of the graph look like? Well, we just want to do a table of values. So if I make a table of values, x and y, and just do some numbers, -2, -1, 0, 1, 2. So I'm not going to do the substitution on the page. Feel free to do it on your graphing calculator or whichever. But if I take -2 and I put it into the function, -2 squared is 4, minus 1 is 3, therefore we get 1/3. And we will continue like that, undefined at our asymptotes. If I put 0 in, 0 squared is 0, minus 1 is -1, and 1 divided by -1 is -1. And if I put 2 in, 2 squared is 4, minus 1 is 3, and 1 divided by 3 is 1/3. So I can plot all these points. -2, 1/3, 0, -1, and 2, 1/3. And again, close to the asymptote, through the point, close to the asymptote. Close to the point, through the asymptote, through the point, close to the asymptote. Close to the asymptote, through the point, close to the asymptote. So now we want to find the x and the y-intercepts. So x-int and y-int. So if I write down the equation, and for x-intercepts, I know y is equal to 0, and I can times both sides by the denominator. Now when I times both sides by the denominator, as we've seen before, the denominator goes away. So 0 equals 1. Is that true? No. So there's no x-intercepts. So let's go for y equals the same function, 1 over x squared minus 1. And for y-intercepts, I know that x is 0. And 0 squared is just 0, so that's just 0. Therefore, y equals 1 over -1, which is just -1, which means our y-intercept is 0, -1, which we already got from the graph and the table of values. So lots of different ways to graph these things. Let's now take a look at how you can cross a horizontal asymptote. So, multiple asymptotes. Now let's see another equation. Y equals x over x squared minus 2x minus 3. So I can draw a little graph there. So let's start off with our vertical asymptote. So vertical asymptote means denominator can't equal 0. equals 0, can't equal 0. We're going to go back and forth. The vertical asymptote is equals. The domain is can't equal, as we've seen in the notes. So now, this time I actually have to factor it. So I'm going to set up my factors. Two numbers that multiply to get x squared are x and x. And the numbers that multiply to get -3 and add to get -2 are -3 and +1. And if I set both my factors equal to 0 separately, I get x equals 3, one of our vertical asymptotes, and x equals -1, the other vertical asymptote. So, given my graph, this is going to happen all the time. I know that if I prepare better in the future, that it will look better, but lots of the times I'm just going to have to extend my graph accordingly. So I have an x equals -1 vertical asymptote and at 3. So notice it's running into my work. Don't care. Now let's look for the horizontal asymptote. So we remembered that we're going to look at the exponent of x on the top and the exponent of x on the bottom on the leading term, and 2 is greater than 1. And if the exponent of x is higher on the bottom than the top, then we know the horizontal asymptote is y equals 0. So I can draw that horizontal asymptote in. And then we're going to do all the other stuff. We're going to graph with a table of values. We're going to find the x and the y-intercepts exactly the same way we did on the last question. So feel free to try those on your own. And I'm just going to put all the points from the table of values into the graph and from finding x and y-intercepts. So I'm going to do this one in blue, close to the vertical asymptote, through the point, close to the vertical asymptote. Now this center bit's a little bit confusing. So I highly suggest testing more points into the table. Checking a value in the table of values, such as -1/2. And if you do that, we can find out that the point is going to be positive, which means I just know the point is above the x-axis, which means that I know that I'm going to start close to this vertical asymptote, through the point or points and close to the asymptote. Before, we saw a u in between. This time we're going to see this. I'm going to go back to blue because it gets kind of messy off to the right-hand side, close to the vertical asymptote, through the point, and then I would go close to the horizontal asymptote. Notice the graph. Take a look at the graph in the notes. It's a lot clearer. Put it in your graphing calculator. Make sure it looks the same. But outside of that, again, vertical asymptotes, horizontal asymptotes, table of values, x and y intercepts, etc.